Okay, on page 203, we have an exploration that we're going to be dealing with that is going to explore end behavior of these different types of monomial functions, and then hopefully when we get done we'll see some patterns and we can make some conjectures about how these functions behave in general given the equations. So we'll start with y equals 2x cubed. That's the first one they ask us to look at. And if we graph y equals 2x cubed, and they asked us to use the window -5 to 5, and then -15 to 15, -15 to +15. So if we graph it, it looks as such. So the first question then, if we're going to describe the end behavior, we do that with limits, remember. As x approaches infinity, in other words, as this function goes off to the right, what are the y coordinates like? Getting bigger or smaller or going to a certain number? They're getting bigger. So if I write down the first one, my first expression then would be the limit as x approaches infinity here, okay, would be infinity. Okay, as x gets bigger, okay, what does y do? Okay, the answer to that question is what goes here. Y gets bigger also, so that would be infinity. Now if we look at this one going off to the left, as we go off to the left, what's going on with the y coordinates now on the left side? They're getting what? They're getting smaller, so therefore they would be going to negative infinity, and therefore my end behavior would be as such. So this is how we describe end behavior of functions. We write them in limit statements. We write the limit as x approaches infinity, and then we write the limit as x approaches negative infinity, and then whatever the y coordinates are like, that's where we put our answer. Okay. Now they asked us to do in part B, they asked us to do y equals -x cubed. So -x cubed, if we go back into our y equals, we change that to -x cubed, or the opposite of x cubed. We can see that that one has end behavior that's going to be different from the first one, because going off to the right, okay, the numbers are getting what? They're getting smaller. And if we go off to the left, okay, as we move left in this function, okay, they're getting bigger, so the end behavior this time would be exactly the opposite of what we put for the first one, wouldn't it? Fair enough? Alright, then the third one they asked us to look at was x to the 5th. So if we do x to the 5th here, we graph y equals x to the 5th. We can see that it almost looks like that same function we started with, doesn't it? Okay. So if we had to describe its end behavior, we would say as we approach infinity, okay, the answer is infinity. As we approach negative infinity, the answer is negative infinity. As we go off to the right, the y coordinates get bigger. As we go off to the left, the y coordinates get smaller. Okay. All right. And we can also look at the third one, the fourth one they asked us to deal with, which was y equals 0.5 x to the 7th. And if we look at its graph, and actually that was supposed to be negative, wasn't it? Negative 0.5 x to the 7th. And we can see that that one looks very similar to the second one that we did. Okay, the infinity answer would be infinity, or negative infinity, and then going off to the left towards negative infinity, function's getting bigger, so that would be infinity. So it essentially would be the same answers as we had for these two. Now, is there anything that we notice then? Because if we're going to make a conjecture about this, is there anything that we notice about these functions, okay, and their end behaviors? Okay, I put a little label on here, letters A and B. Those two have the same answers. Okay, and then C and D, these two have the same answers also. Okay, what is it about these two that are different from these two is the first thing we should recognize. Austin? Okay, so we call that what coefficient? What coefficient do we call that? The one that's on the highest power term? That's the leading coefficient. So the leading coefficients here are both positive. The leading coefficients here are both negative. Okay. So could there be something said for this situation when we have a monomial function? And again, I have it labeled as a power function, but it's a monomial because we're going to use only n greater than, or n is an integer here. N has to be 1, 2, 3, a positive integer, I should say. And so we're going to say in general, if these are monomial functions, and I'll put that stipulation right over here, the fact that n is going to be a positive integer. Okay, that makes it, instead of a power function, it makes it a monomial function, okay, which is just a special case of a power function, of course. But ultimately, if we have functions like this that have positive integer powers, okay, monomial functions, there's clearly something different in the behavior when a is greater than 0 than when a is less than 0. Everybody agree with that so far? Okay. Now, I'm not going to make a final conjecture. We can see that there is some different behavior, but what I want to look at is if we were to look at part B here, and we look at negative 3x to the fourth, let's just see what happens here. We look at negative 3x to the fourth. I have half of the answer already on here. Okay, that one looks like this, and you can see that as we approach infinity, as x gets bigger, the y's get what? Y's get smaller. Okay, so that would be negative infinity. And as as x gets smaller, what's going on with y as we go to the left? They get smaller on that side also. So unlike the ones that we had on the previous page, this time the end behaviors are the same, aren't they? Instead of one going to infinity, one to negative infinity, this time they're both to negative infinity. True? And if we were to look at 0.6x to the fourth, and we can see on that one that it's more like a parabola that opens up. The infinity answer is going to be infinity. The negative infinity answer is also going to be infinity. Okay. So in these two cases, both end behavior answers are the same. They're either both infinity or both negative infinity. Okay. Again, you can see that there's a difference here because of the leading coefficient again. Okay. The negative 1 gave us negative infinity in both directions. The positive leading coefficient gave us positive infinity in both directions. Okay. And so the ultimate question then is, we can see that there's something about the leading coefficients giving us answers. Okay. But what else did we notice about the previous page from this one? Okay. Same here, but the other were opposites. Okay. What was different about those functions that we did on the first page compared to these functions that we have now? The degrees here are all what? They're all odd here, and on this page they're all what? They're all even. And I could do this with any even function that we would see the same behavior. So let's go ahead and make that conjecture now finally. Okay, here's what it's going to be then. I have it. Okay. So we're going to start with even n values, so even degree. So if we have the coefficient is positive, the leading coefficient is positive, and we have n being even, okay, leading coefficient negative and n being even, okay, the following are always going to be true. Okay. So again, if a is positive and n is even, both going to infinity and negative infinity, okay, the end behaviors are going to be infinity. Okay, so going left and going right, okay, this type of function is going to grow, going both left and right. If n is even and a is less than 0, then the limit in both directions is going to be negative infinity. In both directions, we're going to be moving downward as we go left and right. Okay. Questions so far? Austin?
For the bottom left one, is that x to negative?
Yeah, infinity, negative infinity. Just wrote it kind of small there, sorry. Okay. And let's go ahead and make a conjecture about the odd powers. If we have odd powers, then, and again, keep in mind this is the column where a is greater than 0, so positive leading coefficient. So when we approach infinity, it's going to be infinity. When we approach negative infinity, it's going to be negative infinity. If the leading coefficient were negative, then it's going to be the opposite. Okay, this one, as we move to the right, gets smaller. As we move to the left, it gets bigger. Questions so far?
We did that up there.
Mm-hmm. Okay, while you're finishing up writing that down, any questions on end behavior? And again, one thing that's nice is that now that we know this, okay, if we were just given some monomial function, we should be able to look at it and know exactly what it's going to look like, shouldn't we? Okay, at least at infinity and negative infinity. Okay, we should know that it's going to have one of those general shapes that we looked at earlier. Okay, we know that it's going to be either going up as we go to the right or down. Okay, and the same thing going left.